name is Tim Potter, and sort of among other things, I lead the analytics framework team. It's sort of nicknamed the Smart Data team in Fusion for Lucidworks. And so, today, to be honest, it feels a bit awkward to sort of talk about something sort of as mundane, seemingly mundane as SQL, at an AI-focused conference. I just came out of a talk where they're indexing 100 billion docs and that sort of thing. But, the reality is, and I see this working with customers and our field people, is, as search engineers, we are sort of being asked to tackle a number of, more and more complex problems, that I've actually seen require sort of, just basic relational thinking and data analytics. And, while it's not sexy, it's actually, very, very important on a lot of these search projects. Not an exhaustive list by any means, but, I'm sure you can basically identify with some of these being asked of search engineers. So, we're always looking for better relevancy in most cases, but, at the same time, less manual tuning, right? Relevancy is great, but if you have to tune everything by hand, it's tough to get there. Anybody's data sets getting smaller? Yeah, right. So bigger and bigger scale. You asked for these servers, we gave them to you. It's not our problem, right? If you have a lot more spike in volume. So, fixed resources. Another one, higher QPS, but at the same time, like more complex query pipelines, query intent, NLP stuff. But we also want to support faster and faster queries. Another one that comes up actually more recently now that we have like the App Studio offering with Fusion is sort of this idea of we want more sort of bespoke search-driven applications and churn those out faster, right? I've seen this in other places where search kind of becomes addictive because of the speed and the power of facets and those sort of things. And so everybody wants their kind of search-driven application. Another one would be like trying out new ideas, right? Rarely is, the version 1 of a search engine or ranking strategy or what have you that comes out is like what we end up with, right? Like that's always evolving. And so I'll talk a little bit about sort of experimentation and what we have in that regard. And then, one that kind of my team deals with a lot is all this data is sort of flowing into Fusion, Solr, more and more critical applications coming online. People want to then, ask new and different questions about that. So self-service analytics, and I see a couple of the field folks from my company in here. They can definitely identify with this. Just random one-off jobs that come up all the time in a project, right? A common one I see is like moving data between an analytics cluster and the production query cluster. That one comes up type. And of course, in the spirit of this conference, people want to now use AI everywhere, whatever AI means to you. So, I probably gave away sort of the punchline to this to this slide, but, when I think about, well, to deal with all of those, obviously Solr's in there, and that's critical in the foundation, but some of those other like one-off jobs and self-service analytics and things, I think we want a solution that, first off, for me, I've always found to be very useful is, is this technology easy to explain to your boss, right? Typically, these are very busy people, right? And they don't have a lot of time to get into the nuances like you do as engineers. But if you can explain it to their boss and they understand it, they're a lot more sort of willing to promote it and help you bring it to the organization. Most of these are pretty obvious. Another one I see is sort of resume friendly, like you got to do what you got to do, but people like to gain skills and acquire expertise in technologies and solutions that they can kind of take to the next job, right? Especially in this business, people move around a lot and that sort of thing. So, for me, that one's a big one for just attracting talent and being able to hire people because they're going to be able to work on something that they can take to the next place, so to speak. And then, lastly, for me, this one's big, is people want to feel productive, right? And so for me, obviously the talk is titled SQL and Fusion. So we're going to walk today through some of the capabilities that we have in Fusion to address things that came up on the previous slide, and we'll see if sort of what I show today kind of meets this checklist, so to speak. Before I do that, I want to actually tell you, like, I'm obviously a Solr person, co-author of Solr in Action with Trey, and in my job previous to Lucidworks, I was also a big data engineer, all Pig and Hadoop and all that crazy stuff. And we had this developer on the team who was really sharp, but he wanted nothing to do with the Hadoop stuff, right? He just wanted to stay away with it. And for various reasons we don't even get into, I actually brought Hive into the architecture as kind of a central piece of our architecture. If you don't know what Hive is, it's basically like kind of gives you relational database and SQL access on Hadoop for large data. And like almost overnight, this person's name is Brandon, like became one of our top contributors, just like using Hive and SQL, because he was an amazing Postgres DBA, but didn't want to mess with Hive and stuff like that. So like, you know, we immediately added by having SQL as a tool set in our big data stack, like a new developer overnight. And I mean, how many people in here actually will consider themselves sort of adept, skilled at SQL and relational databases? Okay, probably half, I'd say, maybe not quite half. That's cool. Okay, so let's just dive right in. The first one I want to talk about is something I see in a lot of projects, is like projects getting started, and ideally there's a connector, right? And Fusion has lots of connectors, but the reality is there's also, you know, I think for any connector, like a SharePoint system or whatever, there's probably like 20 different other databases and data silos around the organization that you could probably source data from, right? And so it ends up just being this sort of source of friction in a project getting started. And like, show me your hand if getting data index is like the end of your project, right? Yeah, exactly. You want to get to the fun stuff, the queries, the data visualizations, that sort of thing. So any kind of friction on getting data ingested, right, just slows the project down and everything like that. And so what I'm going to show, I'm going to do a couple demos as well today, is what we call the parallel bulk loader. And it's sort of tagline to me is like, get to the fun stuff faster, like get to the queries and building these bespoke search applications and that sort of thing, get in the hands of the users. But before you do that, you have to get the data indexed, right? And so we obviously have a set of very nice connectors in Fusion, and it's great if they have one, but a lot of the times there's data over here in some silo that they want to pull in and whatever. So we've included the parallel bulk loader, and what it does is it actually leverages Spark SQL to basically call out to remote systems, and I'll show a little brief demo going out to S3 here in a second. So hopefully the internet connection's still up. But the cool thing about it is that the connectors that the bulk loader use were actually written by like the source systems experts. So for example, if we're calling out to Cassandra to pull in rows from some column family, the Spark SQL connector that the bulk loader uses was actually written by a Cassandra expert. And the same story about Elastic. And actually, if you've done anything with Spark Solr, we wrote at Lucidworks the Spark connector for Solr, right? So it's like you get to benefit from the popularity of Spark because all of these source systems want to integrate with Spark, and so we actually leverage their connectors, and they're typically written, as I said, like by the experts. So let's dive in. So again, we're kind of built on Spark SQL, but you really don't have to mess with that too much when you're dealing with the bulk loader in Fusion. But behind the scenes, we're leveraging this. It's a very JDBC-like plugin framework for Spark. And so there's like hundreds of data sources out there and data formats, Parquet and whatnot is what I'll show. Obviously, there's one for Solr that we put out as open source. And then there's also like hundreds of built-in functions that you can do basic ETL tasks and aggregation tasks and those sort of things. So let's switch over to that little demo now. I love the little bar here for getting out of that. Yeah, so I should actually say that. That's a very good question. So this is 4.1.1, which is going to be released imminently. But yeah, so some of this stuff that I'm talking about today came in 4.0, but this is 4.1, and so for the most part, you'd have to upgrade to this, to 4.1 to get this stuff. But we kind of encourage that. So this is a bit like a cooking show. I've already kind of baked and prepped most of this, but I went here to the jobs panel, and you can essentially find the bulk loader in here. Now, the reason I called it the bulk loader is because it actually does, when it goes, say, for example, out to Solr, it crafts a query to Solr and will go out to all replicas of all your shards in parallel, and actually it will do intra replica, or intra shard basically reads. So if you have capacity in the Spark cluster, you can kind of really ramp up the concurrency. And we actually use the same worker hash that Joel there wrote for us in Solr to do that parallel read. Right, so that's kind of where it came from its name. But you could basically, to do the parallel bulk loader, I already have one mostly cooked up here. Let's see if we can get a little bit zoomed in. The individual fields aren't as important, so just quickly, like there's a format, and every one of these downstream systems like Cassandra and Elastic, they all have a format. And then you provide a path. In this case, I'm actually pointing out to S3. I'm just going to pull down some Parquet data. So it's also nice for just like pointing out to cloud data and pulling it in. And again, this will happen, and the reads from S3 will actually be parallelized, assuming the data is splittable. And then I can write, excuse me, I can write out directly to a Solr collection, which gives me probably the most throughput, because you now have Spark doing a parallel read out to S3 and then writing directly to Solr. Or we can actually send to an index pipeline in Fusion to give you kind of that more maximum flexibility that you're looking for. So in this case, I actually am sending to the pipeline. And let me click under advanced here. So a couple things are going on in the advanced scene. So first one is there's this Spark ML pipeline model. The talk that Kieran, who's on my team, is giving right now in another room, he's talking about this, but you can basically train your own models like in Spark or TensorFlow or whatever and load them up into our blob store in Fusion, and then basically invoke those from the bulk loader if you want to do, say, for example, sentiment analysis or something like that. But you also kind of want to give you some basic just kind of scripting capability on this job. So in this case, you can do a little bit of Scala, and this example is probably a little more involved than I should have for this, but what it does is it's actually loading a model from Spark NLP, which is an extension to Spark, to do, in this case, named entity recognition. So you can write a little bit of Scala. You don't have to, which is great, but you have the power. And then also, you do have the power to actually write on as you're pulling data in from this source system, you can do SQL and invoke all of these different functions. In this case, I'm just basically providing an ID and then outputting the fields I want to send to the pipeline. But if you're a SQL person, you know that you can actually do lots of interesting ETL things in SQL. You could actually even join with other tables here. So you can go out and pull data from another data source. It's just SQL. So you have that full power of actually going out and joining other tables and things like that while the job runs. And then lastly, before, and I'll go ahead and kick this guy off. So it's running. It's going out to S3 over a semi-busy network connection. But, and this is cool, is as I mentioned, Spark NLP is this extension library. You don't have to go download. I'm not going downloading and loading anything in. I can just actually point out to this packages parameter. In this case, it's pulling down Spark NLP. So one of the cool things that Spark SQL gives us is this ability to register packages on their website, and then you can point out to those. And there's hundreds of packages. So again, if I was hitting Cassandra, I would put a Cassandra package here, and typically these connectors all have documentation on what their package name is. It's pretty much a Maven coordinate there. Let's see, how do we do here? Okay, it's running. That's good. Yeah, sure. Yeah, absolutely. So the format would be Solr, and Spark Solr has all these read options. Absolutely. Okay, so that worked. That's always good. So yeah, you see this, like you would put Solr here, and then the various read options, collection, that kind of thing. We actually have a GitHub project that's actually designed exactly for that. It's a little bit more streamlined than you in this, but you could totally use this, and then use SQL in the middle to maybe pull data from another collection if you wanted. But yeah, if you're just moving collection to collection, this works great, and it leverages Spark, so it does it all in parallel. Yeah. Yes, this has the benefit of actually being very, very scalable. Like, obviously, it's a small data set for demo purposes, but you're only limited by the how much you want to scale out your Spark infrastructure and how much load you want to put on your Solr. So I should probably use Fusion for this, but I'm here, so we'll. I think it was Spark NLP. So query. So the data I had there was just like a training data set out there, and what I did is I extracted named entities. So as you can see here, there's person, location, that kind of thing. That's kind of small, but that's what the bulk loader did with that model, that skull I showed earlier. Okay, so let's switch back. Sure. Yeah. There's a trained model that the Spark NLP project puts out. If you haven't checked that project out, it's very cool. They have pre-trained models, and so all I did was point out to that package to pull the models in, and then I had that little bit of Scala to actually invoke the model. Cool. Okay, and then some of the slides I'll switch over. I just put them here as placeholders for those that actually just look at the slides online. Okay, so that's sort of data ingest, and I think the cool thing about the bulk loader is that it's there for when you don't have a formal connector, or as the gentleman over here said, I need to ramp up like performance. I need to really move some data. Again, it's in its name, bulk, so that's what it's good for. So let's now switch to another problem from my slides. There is using user feedback to improve relevancy. Right. This is one that I hope most search engineers and search people can identify with. But let's just work through some requirements here. So maybe the observation is that ranking is suboptimal for many of your queries. Right? How would you get to that thing? You would probably do maybe an analytics job with SQL and Fusion, and our MRR is a bit off. But that's our problem. And then what we have are in Fusion. We basically keep signals when a user clicks on a document after a search and things like that. We keep track of that. So we want to basically boost some docs based on user click behavior, right? So turns out that for query X, people tend to click maybe on the 7th doc more than the top doc, right? So you want to boost that 7th doc. But hey, Halloween's coming up, so be careful when you buy like costume items on Amazon, because they keep recommending them to you for a long time. But we basically want clicks to sort of age out over time. That's a common requirement. Some actions are actually more important, right? Just clicking on an item isn't as important as like adding it to your cart. And then obviously when you check out, that's even more important. So actions have different weights. And then other times you need to actually go out when you're doing this, and maybe you want to aggregate not just query docs, but maybe query and a property, such as the category on a doc, right? So you can basically go out and join with other tables. I'll show that in a second. And then this one comes up quite frequently is we want to do some crazy function, but we really want to kind of hide it behind a nice interface. And in this case, SQL has UDFs, user-defined functions, and user-defined aggregation functions, right? So you can plug those in Diffusion if you want to kind of do something more complicated behind the scenes. Maybe you want to invoke an ML model and hide that behind a UDF. And then the last thing is like, again, a lot of this is going to change and you'll have different needs and things like that. So you want something that's like easy to change and kind of work on. This slide is just placeholder for the flow of how signals come into Fusion. So as you can see, it's not just somebody clicks and then it's indexed. There's a lot of things going on there, and I actually have a link in the slides for the description of the steps there, which comes from our Fusion docs. So let's do a demo now of the SQL aggregations and kind of see another use case of SQL. Am I doing on time? Pretty good. A little too much talking at the conference. The voice is going on me. Okay, so back to Fusion. I need to zoom a little bit. And we're actually going to switch over to a different app. Okay, so when you have an app in Fusion, some built-in SQL aggregation jobs come in, like for example, this session rollup. I won't talk too much about this, but I'll kick it off just so that some of these reports and insights actually get populated. But let's talk about the click signals aggregation. And this SQL job actually is designed to address a lot of the requirements that I talked about on the first slide. So what we have here is just a way to build an aggregation using SQL, okay? And the first thing you'll probably notice is like, well, Tim, I don't actually see any SQL here. So this is kind of just a nice form built up for our out-of-the-box jobs, which allow you to just kind of tweak these parameters. Remember I said maybe carts are more important than clicks and purchases, et cetera. So with this job, you can basically have replaceable parameters in the SQL. That's just a nice thing to have. But let's go under Advanced and actually take a look at this SQL. And I won't bore you with all the details. I have a slide that kind of, I don't know what it's doing there. It's like it doesn't like my zoomed in, I think. I don't know what it's doing, but let's zoom that in a little bit there. Let me just refresh. The thing should open up like a full SQL dialog is what we're after here. Okay, I guess not. But so so what we're doing essentially is just there it goes. It was just being a little laggy. Maybe I was running that other job, but you know, I'm selecting signal data. This with stuff is really just for organizing your SQL. And you can see I'm doing a left join. In this case, it's not interesting. I'm not going out and getting anything interesting. I'm actually doing it because it's a way, it's pulling, like enriching the signal with some data from another signal. But again, you can go out and join from different tables that exist out in Fusion, and they actually don't even have to be Solr tables. Fusion allows you, because we leverage Spark, to just register any remote data set. For example, like Cassandra table, you can register that as a view in Fusion and join it here. Most of the time, they're Solr collections. And then, as I mentioned, we want to do like this time decay, so these signals sort of over time, and I apologize that the zoom is not working, kind of age out. And then also, here's another example of a UDF invocation where I'm going to go ahead and, in this case, it's an UDAF, an aggregation function, and I'm just going to go ahead and create an aggregated sum based on the different types using those signal type weights that I showed, right? So not too much going on in the SQL here. It can get a lot more complicated, but I think it gives an idea that basically you can do a lot of things with your signals and your data and aggregation just with very pretty straightforward SQL and these functions that we have built in. So go ahead and run that. Again, it's just another Fusion job. And so what it's doing behind the scenes is it's querying I should show this, the source collection, in this case our signals, and it's writing out to signals aggregation. And then we have a stage in Fusion that can actually hit that signals aggregation collection and use these weights computed for queries to kind of boost these documents up, right? So at this point, we're just aggregating the data and caching it in another collection, so it's fast at runtime. Pardon me. That should be done. Yeah. Yeah, so not a lot of data in this collection, but basically it aggregated 579, and it just created sort of aggregated docs that stage, as I mentioned, uses. And these docs kind of look like, right? So you have and this is the Kaggle Best Buy data set. So you have this is a different, this is output from a different job, but they're aggregated rows there. We don't really need to look at those. Okay, so then one more thing is, if you recall, this is kind of a built-in job, and we have a little bit of Chrome around it, to make the form better, but you can actually just go in yourself and build an aggregation and write the SQL you want. So it doesn't have to actually do aggregation. It can do any kind of relational data flow thing here, right? Moving data from another and using SQL. Aggregation is the most common one, right? And if you remember, I kicked off at the beginning was this session rollup job. And its SQL is a bit more cumbersome, but what it's doing is actually taking the sessions that we track in some of our signals and rolling up over them so that we basically count, like what's the average number of uses for that. And then that all gets fed and used by the App Insights in Fusion, which I don't really have time to go into, but excuse me. You can see here we have like set different types of signals and things like that. So this thing actually uses the output of that SQL job. So you can basically use these SQL jobs to like drive dashboards and things like that as well. Let me switch back to here. And so again, I've called out a few things on that SQL in the slides there. Another one that's interesting, actually, I have full power of like window functions in SQL. So this one here actually finds sessions in log data and then does some aggregation, right? And it uses a lag function to do that, right? Like if there's so much time between activity in the log by the same person, we kind of consider that, the end of a session. And so you can do very powerful things with like these window functions and things like that, but I'll just kind of leave it at that. So again, I mentioned like data sets are getting bigger. Let's talk a little bit about sort of SQL aggregations and the scalability, because we didn't build this for just like these Tinker Toy data sets that I'm showing on my laptop, but we have one data set that has 42 million signals, and then it actually aggregates down into 11 million groups when you group by query and doc ID. So not too much compression there, but not bad. And then on the little 3-node cluster, just R3X larges, which aren't beasts, but they're decent. I believe it took about 18 minutes, which doesn't sound that fast, but it's actually, I'd say 90% of that job was all just I/O out of Solr and then back to Solr, right? Because you're moving 42 million rows out of Solr into Spark, doing the SQL thing, and then writing back 11 million rows to another collection. So it's mostly I/O there, but you can get that kind of gives you an idea of the speed. And so, the nice thing here is that if you need faster, you can scale Spark, and that's a kind of a solved problem, as well as scaling Solr. So you can really ramp these jobs up as needed. Okay, so now we're going to switch over to last couple. Basically running out of time. I have about 10 minutes, so I won't spend a lot of time on these. But another one we see. And did anybody take the SQL class, the Fusion SQL class? Okay, good. So this will be useful information for you. So one of the things we see is actually, a lot of these data sets are ending up in Fusion, and they're being used to power search-driven application, things like that. But people actually also want to do self-service analytics, ask new questions, pull data from different collections. So it's not so much we can do the right thing and denormalize everything into one collection. Like, I think somewhere on my slides I had like, you know, the modern organization is very adept at like creating data silos. And so one of the things we see is people want to be able to offer self-service analytics, but what does that really mean when you kind of get behind the scenes? If I was like a CIO type, I would be very, very nervous of letting somebody fire up like a Tableau and point it at like a 100 million row collection, right? Like, A, that's gonna kill Tableau, and B, like I don't think Solr would be very happy with like the query that gets sent there, right? So you have to be pretty cautious when dealing with very large data and self-service analytics. And then on the flip side, like users don't want to come in and have this great tool to do dashboards and things, and then everything they do, click, like is super slow. That's so frustrating. So what we have in Fusion is basically, we call it Fusion, the Fusion SQL service. It's actually a JDBC service. It's built on Hive and Spark. And what it does is Spark will parse the SQL and give the Fusion SQL code a logical query plan. And then what we do is we walk that plan and decide how to translate that into an optimal query, right? And so we can, this slide kind of walks through how sort of all that works. The key thing here is that we have essentially in Fusion SQL the ability to plug into the query plan and say, oh, you're doing a group by and an aggregation, in this case maybe an average. Well, for those that know Solr, you're kind of, you know, bells should be going off. A group by and an average in Solr is just a facet, right? And computing a stat from that facet bucket. So let's go ahead and fire up Tableau. I just want to show this really quickly because I think the key takeaway here is this doesn't replace Banana and, you know, like Solr driven in these, you know, App Studio based search apps. This is for organizations that have already invested in like a BI tool like Tableau. It doesn't have to be Tableau. We've connected to Power BI and Spotfire and those sort of things. They've already invested in those BI tools and they want to actually just connect them and do some more self-service type use cases. So I'll fire up Tableau. I'm like the only person that has a Tableau license at Lucidworks. And then all I'm going to do basically right now is connect to Fusion SQL. And so I use my Fusion credentials. And this is going over JDBC using a built-in driver that's already in a lot of these tools. Again, that's kind of our benefit of building on top of Spark is, again, Spark's been kind of popular. So a lot of these BI vendors have integrated Spark support. So what I did is just go and read the default schema, and it has all of my tables that actually exist in Solr. And so I can drag these out, and I'll just do a quick movie lens one. So it's hitting, so that's hitting Solr. I'm going to do a quick join between movies and ratings. This is a movie lens data set. It gets the join wrong because the ID is not the movie ID. Okay, so just set up that little inner join. You can look at the data. So that went out and hit Solr. But let's build a viz really quick, just so we can see. So I'm going to drag number of records. We'll just do a basic facet here. And I will do by rated. Yeah, actually, let's do it this way. That way. There we go. And then, so, what is it? And we'll put a little color. So, again, not the most amazing graphic in the world, chart in the world, but you can see you can actually just, people can actually slice and dice and create these. The cool thing is, switch back to my slides. Is that the performance is pretty amazing, and this is from people in this room actually have done the heavy lifting here. So this was a little thing I found out on the web, and it was this company, and there's a link to the blog, but none of that's important, is they basically did this kind of bake-off. They had like 14 million logs, and the SQL there is just kind of like a count distinct, right? Very facety. And the query on the right I'm showing there is the query 3 in the bottom. And you can see there, And this is after executing the query one time and then re-executing it. So the engine had the ability to get hot, right? And the best one was SQL Server. It's not surprising. It's a solid engine, especially for analytics. But like MySQL was 13 seconds. So I did this on Solr. Through Fusion, but obviously running on Solr. So that query on the 14 million was 900 milliseconds, right? And then I said, all right, well, let's double the data, because that's what's awesome about Solr is 14 million rows, that's still kind of in the sweet spot of some of these relational systems. But when you get into the 28 million rows, 100 million rows, those systems aren't going to scale there, at least not as easily as Solr. And it only went up like, 400 milliseconds. So that was pretty impressive. And then here, this was fun. I tried to actually build some viz, like I just showed you, against the MovieLens 20 million ratings data set. And it didn't go well with MySQL. So that query, which is super basic, it's a join. It's basically an aggregate using facets and then join. That, again, we did on just a single very minimal box in EC2. It was like 1.1 second. And then it was 17 seconds on MySQL. With an index built on Movie ID. So I'm not a great database administrator, so maybe I didn't quite do the index right, but like you got a lot of tuning to do. And then again, it's not 20 million. It's like Solr can go to 100 million, and that's what's really cool. So get us is what we're excited about for the Fusions for self-service analytics. Okay, so lastly, I have a couple minutes, so I won't really be able to show the demo of this, but we also have in Fusion the ability to set up an experiment, right? And the idea there is maybe I have two different ranking strategies. At this conference, people learned about learning to rank, and then maybe you want to compare that to just your own homegrown, hand-tuned, signal-boosted, what have you, right? You could do it, and then you can actually run a live experiment. And what's great is we have some built-in obvious metrics, right? MRR, average, response time, those kind of things, click-through rate. But if you want to run an experiment and then we don't have an out-of-the-box metric for you, you can actually just go in, and I was setting up an experiment. You can actually go in and add SQL, right? Which is great because now you're not limited, and let's see, return to Fusion. I would like to find query profile. Yeah, let me just quickly show you the panel here. Obviously, we won't be able to run the experiment right now. Activate. And so you can do add metric, and then it's just custom SQL, and you can actually put in your custom SQL there, which is nice, and then compute any metric really you can compute with SQL, and our framework behind the scenes actually then computes that metric using the SQL for both variants, or if you have 3 variants or whatever in your experiment. And then the nice thing is we can feed that into a Bayesian bandits implementation that you can actually just like do the explore exploit using your SQL to find which variant is actually better, right? And so we support sort of A/B testing as well as bandits. And then you kind of have all the power you need with SQL there. Okay, it looks like I'm down to 1 minute. So that was that. Yeah, just some recap slides. I don't know what happened there. What is it doing? Anyway, thank you, everyone. Pretty much out of time. So if you have questions or whatever, hit me up out there. I'll just be outside. Thank you.